Hey everybody, Harold here. Uh, Today I want to talk to you about a Python library called RapidFuzz. RapidFuzz is a fast string matching library for Python and C++ for string similarity calculations. It's high performance for fuzzy string matching, ideal for tasks where approximate comparison is needed. And I'm going to give you some use cases. So we can use data deduplication, like if someone put John Smith and John Smith, those would be identified as highly similar, and we could dedupe those. Record linkage. Say you have two data sets and they have different column names or titles. You could use it to match those. Um, Autocomplete, like if they put IPHNE, would say, were you looking for iPhone? Um, all kinds of natural language processing uses, spell checking, and filtering and ranking search results, like how close the match is. So I'm doing this in Google Colab. If you don't have Colab, just go to colab.research.google.com. Welcome. You can get your own account. Check out all this great stuff. Gemini works really good in here for the AI, and then just do a new file, new notebook. If you want to follow along, I will download the whole thing to my GitHub when we're finished. So in Colab, lots of times you have to reinstall packages. So pip install RapidFuzz to install the necessary library. Let's run that. Downloading RapidFuzz, installed. Okay. Now we need some libraries from RapidFuzz and pandas and OS to do data frame and file operations. So we'll import those. 0 seconds. Okay. Now to RapidFuzz. The first thing I want to show you is just the simple fuzz ratio, basic usage. So I like Seinfeld. I'm going to use a lot of Seinfeld examples here for my variables. So string 1 equals hello Newman, exclamation point. We'll say string 2 equals slightly different, just hello Newman, all lowercase, no exclamation point. So then we would say like ratio, create a variable called ratio equals, and here's the RapidFuzz part, fuzz.ratio between two arguments, string 1, string 2. And that needs to be an equal. And then we would print the ratio in Colab. Most times in Python, you would say print ratio. In Colab, all I have to do is say ratio. It understands I want to print it. So the ratio, it's 80% similar between hello Newman and hello Newman, lowercase. Let's take change a few things, see what happens. 88% if I capitalize that. H If I capitalize the N, 96%. And if I put that exclamation on, let's go for 100. So you can see simple fuzz ratio tells you how close it is. If I put hello Jerry, now it's only a 64% match because Jerry doesn't match Newman, but hello and the exclamation point do match. You can do partial ratio. So partial ratio matches a substring when one's contained in another. So I could say string 1 equals Jimmy likes Elaine. And I keep not putting equals there, sorry. String 2, that could be, we'll just say Jimmy. Then we'll do the regular ratio. Fuzz ratio, string 1, comma, string 2. And then for comparison, we'll do ratio equals fuzz dot partial underscore ratio, string 1, string 2. We better call this ratio partial. So let's run that. Let's run ratio, comma, ratio partial. So Jimmy likes Elaine and Jimmy, it's only 43% similarity. The fuzz ratio, the partial ratio, since Jimmy is the substring of Jimmy likes Elaine, that's going to give you 100% there. So that's partial ratio. Ignore words. The next is token sort ratio. So string 1 could be token sort ratio ignores word order. String 1 could be, let's say, Kenny Rogers Roasters. And we'll copy that down, Alt Shift down arrow, and say string 2 equals Roasters Kenny Rogers. And we will do all of these. And we're going to add our token sort. That's buzz dot token underscore sort underscore ratio. String 1, string 2. And let's add ratio token sort to our list to print out. Now we'll add ratio token sort. and see what we get. So fuzz ratio between those are pretty similar. 57%, above half. I would think it would be more than that. The partial ratio, 72%, because the phrase Kenny Rogers is included in Roaster's Kenny Rogers. And token sort ratio, we're going to get 100% because it's just a rearrangement of the three different words. So it ignores the order. They perfectly match. If I put in Kenny Rogers Roaster's rules, it's going to take it down some because I added something that's all in there, but it's not the exact same words. There's an extra word. Um, Token set ratio. Let's match common words. Um, this one's a little different. So how many words are common? I'm going to give you this example. So string one equals the, this is going to sound weird. It's just for demonstration. Soup Nazi, can't spell soup. Okay, I've got the soup Nazi, the string two equals Nazi soup, the, and more stuff. So let's copy all these down again. First and sixth. We'll add ratio token set and ratio token set equals fuzz dot token set ratio string one string two. All right, now let's run that. So fuzz ratio 40%, partial 53%. You know, soup Nazis contained here, but not the same word. Token sort, the soup Nazi and the soup Nazi, the soup Nazi and Nazi soup the kind of match, so that's better. Um, so it had a lot of common words: Nazi soup, the, and more stuff didn't. So it's 81% on the token set ratio. Now, besides fuzz, there's process. So we're going to use process to find best matches. Since this is all on my GitHub, I'm just going to paste in the data here for the quote string. So we have some Seinfeld quotes. No soup for you. Pretzels are making me thirsty. Serenity now. Yada yada yada. George likes his chicken. It's usually just spicy, but I put very in there for test purposes. And the sea was angry that day, my friends. So I want to make a user query. This is it. What a user might input. And I'm going to look for things that are similar to the furry, the string, very thirsty. Now process extract will give you multiple matches. So multiple matches, call this variable multiple matches. equals, and here we are in the RapidFuzz process.extract, and that takes two arguments. There's some optional arguments we'll get into later. But this should give us a score on all of them. So I want to take user query and I want to compare it to Seinfeld quotes. And I want to get matches and scores for all of them. So let's say if multiple matches, I'm going to print. We'll use an F string here. Top matches. For whatever the user queried. So many of the top matches for whatever the user queried. Print them, and then for the match, and the score, and the index, in multiple matches, I want you to print another F string with match, the match, and score, colon, score, and I want to fix that to two decimal places, 0.2f. If there's no matches, then else if there's no matches, so better do it else. Else, we'll just print no matches found. Okay, looks pretty good. Let's run it and see what happens. Top matches for very thirsty. 85.5% for George likes his chicken very spicy. So it thought spicy was, but only 73 for these pretzels are making me very thirsty, or making me thirsty. Uh, it considered very more than a considered thirsty. That's interesting. The C was angry that day, my friends. Got a 52.5. I'm not sure why. These are kind of useless. The bottom three, I mean, none of those really match. So there is a cutoff argument I'll show you in a minute. If you just want to find the best match, um, let's copy this down. Copy cell and paste it. So you say extract one. Instead of extract, you extract one. It's just going to give you one, the one best match, which should be uh, George likes his chicken very spicy. We'll see. So we'll change the top match. And no match found. So let's run this again with extract1 to get the one batch mass. And George likes his chicken very spicy. 85.5, same as the above. You're just going to get the one. You're not going to get all the other ones. So there are some other arguments. You could choose your score method. With a scorer, and these are kind of long, so I'm going to paste these in also. They're pretty much the same, just using a different kind of rapid fuzz command. So score. Got the Seinfeld quotes. The user query I've changed to soup. Best match partial. I'm doing an extract one for the best match. My user query, Seinfeld quotes. Now I've got an additional argument here that's optional. I can tell process extract one which score to use. So I've told it fuzz partial ratio. I've told it to print a best match using partial ratio in the score. And if that's not there, print no match found. So let's run that. So the best match partial ratio to soup is no soup for you, 100%. Uh, let's try very thirsty here. That should give me the pretzel one. 8182. It's not partial, but the word is in there. Okay. So that extract one gave me just the one. What if I wanted to do some process extract, which returns all of them in their scores, but I wanted to limit it. So I would do something like this. I want to use the user query then I'm going to make a multiple matches limited variable that does process extract with the user query and Seinfeld quotes, but I'm going to use this third argument limit. I'm going to limit to 3 and put that limit number in there and say what they are and their score. So let's run that. So top 3 matches for are the contest. Jerry, these are load-bearing walls, and these pretzels are making me thirsty. Well, that 40 doesn't belong there. Now, I could limit to 2 to fix that, but I could also use cutoff. So here's another one, the cutoff. Quote quotes, a little bit different, but user query very thirsty. Best match with a cutoff. I'm using process extract so I can get, it looks at them all, but I don't want any that are less than 50% similar. So my score cutoff is 50. Then I want to print matches found with a cutoff, and if nothing was above the cutoff, I want to print nothing. So let's run that. All right. Matches above the cutoff are very thirsty. At 50, where George likes his chicken very spicy, and these pretzels are making me thirsty, and the sea was angry that day, my friends. I don't know what that has anything to do with it. So maybe we need to adjust our score cutoff to 70. And then we just get those first two that are above 70. Now I want to get to a little more practical example, use case. How to we would search a database from user input. First, we're going to upload a product CSV to use for this. I will include it in the repository. To upload a file, you go to the file folder, upload to session storage. These will not stay there. Once you close your session, they'll go away, and you have to load them again every time. But here's my product CSV. So open that. It's going to warn me that files were saved elsewhere and will be deleted when runtime is terminated. That's okay. So I've got my product CSV over here in my files. To make some nice code, we'll just give that file a variable name. So we'll say CSV underscore file equals, you give it the file name. The easiest way to do that is copy path on the right click, paste, content product CSV. Let's run that. Okay, it seems to that work. So we've declared our CSV file name as a failure variable. Let's make sure the file exists. It's just to check to see if that file is actually there. If not, this is from the OS library, os.path.exists. So if the operating system path doesn't exist, for CSV file, then I want you to print an F string. CSV file. We're going to use pandas to upload the data frame and check for errors. So I'm going to try to say def equals pd read underscore CSV. And what do I want to read my CSV file? Except if there's an error. Exception is E. And then I want to print F string, error, reading, CSV. And that's CSV, and the error message. Let's run that. Seemed to work. If that file wasn't there, it would have told me error reading CSV. Well, let's show you. You have to read CSX file. Error reading CSV, so our error message worked too. Just a little test there. Control enter, run the cell. Now let's check out the top 5 rows of our data frame. Well, let's check out 20. Just to see what all we got for some comparison. So df dot head 20. Okay, I got product ID, product names, data frame is beautiful, category, price, stock, category, price, stock on hand, supplier, and the data was added to the inventory. Beautiful. So my data frame is ready to query. So if product name not in div columns, print column not found. Columns are list div columns. So that product name was found. If it wasn't found, oh, we should probably break here. So exit. It's going to list the columns and exit, make you start again. It's just for a test environment. Um, let's go ahead and just see what the product names are. We'll extract that into a list. Equals df. And we can just put the column in square brackets. Let's use single quotes. And put it to a list. And call it. And of course, we need to print it out. So there's all 50 products. There's some wireless duplication, some other things, camera, Bluetooth, repeats. So there are some repeating things. So it's good for our example. Go ahead and get a user input. And to get input in Python, you put input in a string. Search products by name. I like to strip that. I like to strip that in case the user put in any unnecessary spaces. So we do that. And let's search for wireless. It's accepted that argument. Let's put a check in here. If there is no user input, we'll print. Input provided. Yeah, just for our test program here, we'll exit. The colon there. And not a quotation mark. So there was input. Now we want to find our match. We're going to use cutoff 60, but you can adjust for higher matching. So basically, our result is going to equal process dot extract one. Remember, we're only looking for the best from our user compare our user input to the everything in the product names list. And let's give that a score cutoff of 60%. Similarity. So if it found the best, if we got a result, it's going to say best match found. Match product, product name, ID, category, price, stock. It's going to give us all the columns from the table. If it doesn't find that best match, it's going to say no close match. So what do we put in wireless? Best match found wireless earbuds. Product wireless earbuds, ID, category, price, stock, supplier. It should not be supplier price. Let's delete that. Run it again. Okay. So that's our best match. Let's go back to the input. Run that again. Let's try, I think I saw electric kettle on there. The best match found, product electric kettle, quick boil limited. Let's do one more. I know there's Bluetooth and toothbrush on here. Let's see what happens. We put tooth. Run these again. Move that code cell down. So best match now is Bluetooth speaker. Okay. So let's do another code. Let's expand this a little bit. Give suggestions. So we could say something like, in case they don't find anything, because um, if I do this, let's just show you another test. No close match found for ADSF AGS. Okay, so let's say, whoa, okay. Give me some suggestions then. We use process extract. Remember, it gives us more than one. All of them. We use process extract, remember, which gives the score on all of them for user input, on product names. I don't want all of them because you get some junk at the bottom. So let's limit to the 3 best matches. If I type plus instead of limit again, so if it finds any suggestions, if there are suggestions, I'm going to print. Let's give it a new line. Did you mean something wrong here? It's just, oh, I need a parenthesis in my print. Possibly mean For sug for in underscore in suggestions. Another print. Have string. Our sug. For each sug. I'm going to print similarity. Colon. And then the sub score. With, let's say 1 decimal point. Looks like we got some issues here. You know another good thing about Colab? Again. Okay, did you possibly mean resistance bands, wireless charging pad, wireless earbuds? Well, that's still comparing to ASDGF, whatever. So let's go back and change our input to, I don't know, let's say Bluetooth again. Enter on these cells below. Best match on Bluetooth speaker with its details. List of the suggestions. Did you possibly mean Bluetooth speaker, a Bluetooth tracker, or electric toothbrush? So that's pretty cool. You can see how that would be great when you had a product database to search and your user couldn't exactly identify the problem or they couldn't spell. Let's try another one. What if they were looking for a camera and they spell it like that? Well, action camera. And some other below 50. So we might want to put a score cutoff here. No, 70. Well, we got the one too. 60. Just playing around. So we did get action camera. Uh, Other suggestions were below, so you might want to do a score cutoff. Maybe 75. Let's go back up here. Smirk. That's the smartwatch. And get smart light bulb and smart thermostat. They ties. So play around with these. They're great for all these use cases I mentioned above. I really like them for the spell checking and search results and autocomplete. And I've used them column matching also for unified schema for a data frame. But that is all I have today on Rapid Fuzz. I hope you like this. Hope you got something out of it. If you do, if you did, please like and subscribe, and I will see you next time. Thanks, everybody.